We'll proceed in gradient vector, usage of gradient vector. Usage of gradient vector. There are some uses of gradient vector that cannot be replaced with any other technology. So, what is the unique usage of gradient vector? What is unique usage of gradient vector? If I have a function fx, if I have a function fx, if I have a function fx, if I integrate this function fx to get in function gx, function fx, if I do integration, then I get back gx. Fx is called velocity function. If I am doing integration, then it is called velocity function. When I am doing integration, it results into gx, and gx is called displacement vector, displacement algebraic equation, velocity algebraic equation, displacement algebraic equation. It doesn't mean that this is velocity one. If it is acceleration, then if I do integration, it returns the velocity. If it is velocity, then it returns the displacement. So this is called velocity algebraic equation always. And then it is called displacement algebraic equation. This displacement can be displacement, can be velocity, can be acceleration. If it is acceleration, if I do derivative, then it becomes deceleration by dt. If it is velocity, if I do derivative, it becomes acceleration. If it is displacement, if I do differentiation, then it becomes velocity. So the function fx, the function fx for which we are calculating the integration, that function results in function fx, which is a velocity function. If I am doing integration, then it results in a function that is gx, that is displacement function. If I need to get velocity, then I need to have a displacement function, and then I need to calculate derivative. If I need to calculate displacement, then I need to have velocity function, and then I need to calculate integration as per the rule. What is the circumference of this circle? What is the circumference of this circle? That is under question. This is x-axis. This is x-axis. This is y-axis. This is x-axis and this is y-axis. If this is the case, then where I keep this? Consider the consider there is a straight line like this. Oh, nice. There is a straight line like this. This straight line here, it intersect at 3 comma 0. Here it intersects at 0 comma 3. This is the line. What is the length of this line between this point to this point? What is the length of this line? If this is a line, then what is the length of this line? If this is the line, if this is the line, then what is the length of this line? Length of this line is 2 pi r. I don't trust. length of this line is length of this line length of this line is 2 pi r. I don't trust. How to find displacement? How to find displacement of a distance of a line? Can someone tell me what is the length of this line? I can measure through a scale. What is the length of this line? No one knows. You can do it like this. Simple, right? If you need to calculate the circumference of a circle, then create a circle like this and then unfold it and you get it. But it may not be exact. What is the length of this line? That is question. Can someone find it? If I have if I have if I have if I have equation of this line, what is equation of this line? Algebraic equation: x square plus y square equal to a square, where a square is the radius. What is algebraic equation in terms of calculus? Y equal to a square minus x square square root. Y equal to square root of a square minus x square. Y equal to square root of a square minus x square. If that is the case, y equal to square root of a square minus x square, if that is the case, then this is calculus algebra. Independent component is x and dependent component is y. Y equal to square root of a square minus x square. What is algebraic equation? X square plus y square equal to a square. If I calculate gradient vector for this algebraic equation, that it comes perpendicular to the line. This is what we have seen. But if I represent this circle as a position vector, if I represent this circle as a position vector, okay, if that is the case, then gradient of this position vector is tangential. This is what we have seen. We got the answer. We got the answer. If I have a position vector, if I have a position vector, if this is the position vector, if I have a position vector, okay, so consider up to this only. The length is up to here only. Up to here only. This is center. If this is center, then from center, if this is center, okay, if this is center and this is, I take any point P, this is center and I take any point P, this is any point P and this is center. If this is any point P and this is center, what is kind of the point P represent? X comma y. Then position vector is xi plus yj. If then can we consider this as displacement vector? Simple, because it represents the curve. Can we think of it as displacement vector? If that is the case, then its velocity vector, gradient of this vector is tangent. If this is the position vector in this direction, the gradient of this vector is tangent to the curve. So if point P is there, then at this moment, if this is the position vector, then the gradient of this position vector is tangent at this point. If this is tangent, then first of all, gradient means it is a velocity vector. If this is a velocity vector, first thing. Second thing, wherever this, if P is here, P is here, P is here, P is here, then gradient vector will keep on moving along the curve of the line. Means this gradient vector actually it is representing the curve. Can we see it? The gradient vector is representing the curve. If I do some manipulation of the gradient, like position vector is representing radial to the, this is position vector. This is representing radial to the 90° to the curve. But the derivative of this is representing the curve because it is tangent. It is representing the curve. If it is representing the curve, then can we find out the curve length with the gradient vector? Certainly we can find the curve length if I am able to calculate the magnitude of the gradient vector. Gradient vector is representing the curve, it is going along the curve. If I calculate the magnitude of this gradient vector, then I can get the curve length. But the caveat here is that gradient vector is velocity vector. If I calculate the magnitude, I'll get the velocity. If you have velocity, you know that it is velocity, then do the integration, you will get the magnitude, displacement. Simple, right? If you have velocity vector, this is velocity vector. If you have velocity vector, calculate the magnitude of the value, because vector has nothing to do with calculus. If you are going with integration, then vector has nothing to do with the calculus. Calculus is a game of algebra. So if vector has x component, y component, z component in the function of x, y, z, if you calculate the magnitude, you will land up in an algebraic equation. If you land up in an algebraic equation, then certainly you have a chance to do the integration. What is the flow now? Flow is, first we have position vector. If I have a position vector, vector means it has components, x component, y component, z component. Each component should be function of some independent variable. So if I go with the gradient of calculating the gradient of this vector, the next vector is velocity vector. Velocity vector is tangent to the curve. It is giving a smell that since it is always touching the curve and going along with the curve, it can give the curve length. So if I calculate magnitude of velocity vector, it will result in an algebraic equation. But that algebraic equation represents velocity, not the displacement, because one differentiation is done. If that is the case, whatever magnitude we are getting, if we do integration of velocity results in displacement, then we can get the length of the curve. Theoretically, right? Can we try it? Okay. So we can try. So what is the position vector of any point P? That is xi plus yj. Considering this point coordinate is x comma y. If it is x comma y, then it is xi plus yj. xi plus yj. Now x square plus y square equal to a square, y equal to, okay, so P, position vector P equal to xi plus yj. If I do dp by dx, position vector by x, dp by dx, then dp by dx equal to I plus dy by dx j. This is velocity vector now. I plus dy by dx j. If I calculate the magnitude of this, then it becomes 1 square plus dy by dx whole square plus 2 into 1 into dy by dx square root. I mean, the if I have x component as x and y component as dy by dx, then its magnitude is x square plus y square root 1 square plus dy by dx whole square plus 2 into 1 into dy by dx square root. If that is the case, then dy by dx x square plus y square equal to a square, that is the equation of a circle. Then y equal to square root of a square minus x square. Dy by dx equal to minus x divided by square root of a square minus x square. Dy by dx equal to 1 by 2 1 by 2 divide 1 by 2 into 1 by a square root of a square minus x square, then minus 2x. So minus x by square root of a square minus x square, that is dy by dx. Okay, if that is the case, then here it results into 1 square plus dy by dx whole square, means x square divided by a square. I'm sorry. Okay, so magnitude of 1 plus x plus y, magnitude of xi plus yj is the square root of x square plus y square. So here magnitude is square root of 1 square plus dy by dx whole square. That's it, not 2 into dy by dx into 1. So the magnitude of a vector, so position vector is xi plus yj, then dp by dx is I plus dy by dxj, then magnitude of this velocity vector is 1 square plus dy by dx whole square root, means 1 square plus x square divided by a square minus x square root. This means that it is a by square root of a square minus x square. That is the magnitude. Now we will integrate along x-axis. Now integration, when line integral has come, the concept of line integral, then I have to integrate along y-axis or x-axis. So dy by dx, then integration of, now we have dp by dx, magnitude of dp by dx is a by square root of a square minus x square. Then I have to integrate with the dx. This is velocity magnitude. This velocity magnitude, I have to do integration to get the net curve length. If I take that magnitude, then it is velocity magnitude. If I need to calculate the displacement magnitude, then I have to do integration. So integration of a by square root of a square minus x square dx, and then lower limit to higher limit. Okay, so x, if I see the axis, then x axis is left side, that is minus a, to right side, that is a, minus a to a. Okay, and this is x axis, then this is y axis, so minus a to a. Everything, mind it that we consider this as x axis. Whatever we are taking in the top quadrant, top half, not the bottom half. Anyway, now a by square root of a square minus x square dx. Okay, what is integration of 1 by square root of a square minus x square? That is sine inverse x by a. Sine inverse x by a, or someone can imagine x equal to a sine theta. X equal to a sine theta. X equal to a sine theta. If that is the case, then a by a square root of 1 minus sine square theta. So 1 by cos theta. And there dx becomes a by cos theta d theta. Okay, so cos theta again gone, so it remains only a d theta. A d theta, then integration is a theta, where theta goes from one point to another point. Okay. So now the integration comes as a theta. If it is a theta, if a sine theta equal to x, then theta equal to x by a sine inverse. This is what I am saying. The integration of 1 by square root of a square minus x square is sine inverse x by a. Okay. So let's go with it. So now we have a theta as integration, or a sine inverse x by a. Now x is minus a to a. When it is a, then a by a is 1. Sine inverse of 1 is pi by 2. Minus, then minus a. Sine inverse of minus 1 is minus pi by 2. Pi by 2 plus pi by 2 become pi. So the length of the curve is pi a. But we have taken x-axis. This circle is centered at the origin. If circle is centered at the origin, then we have taken x-axis like this, and everything we have calculated upper half. So upper half, the circumference is pi a. If that is the case, then full circumference of a circle is 2 pi a. I mean 2 pi a. The length of the circle circumference is 2 pi a. Position vector, gradient vector, that is also called velocity vector, calculate the magnitude of velocity vector, and this magnitude of velocity vector is along the circumference. If I calculate the magnitude, it is actually the circumference. If we integrate it, then we get the displacement, that is the length of the circle. Can someone believe it? It is that easy. This is importance of gradient vector. I have a water flowing. Somehow I get to see a river. Somehow I get to see a river, and water is flowing. Water is flowing. Can I consider this as a gradient vector because it is a velocity vector? It has a direction and it has a magnitude. Now I drop a piece of a paper, small paper, on the water. Small paper, if I drop on the water, then paper starts flowing. Watch carefully, neatly, closely. See if a paper is going, paper or leaf, whatever. Just leaf. In river means there would be tree, right? Just take out one dry leaf, or it is falling on the ground, and just drop it on the water. Make sure it is not rotating, and watch that water is the leaf, tree leaf is flowing, and what's happening in that leaf. If it is passing unrotated, means the velocity vector is straightforward. If I take a closed region, in the water, and if I drop the leaf from the beginning and watch till it crosses the region, if I take a rectangular region and there is no circulation in the leaf, it just passes untouched. This proves that water is entering into the area and leaving the area. And if I consider water as a velocity vector, then there is no curl in the water. Velocity vector, when it is entering and when it is leaving, then it is exactly same. If it is not same, if water is entering into a region, this is a river. On river, I am seeing the river, and river, I draw a rectangle. Okay, and then beginning of the rectangle, you understand, right? This is the region on the water. If this is water is flowing like this, then this is the region on the water. Water, this is big river, and big river, I have taken one rectangular region in the water. Here I am keeping the leaf. Leaf is flowing like this, and it is coming out of the rectangle. I closely watch and leaf is just passing through. It is not rotating little bit also. This proves that water is entering the rectangle and it is leaving like this without having any rotation tendency. That rotation tendency of water, being it is a velocity vector, it is called curl. Curl. If leaf is rotating and moving, this proves that your water is not velocity vector is not simple. It has curl tendency. It has tendency to rotate something. Means the velocity, the water is not straightforward. It is entering and leaving here. There is a change in the water direction. We will see more on it. That is curling. Anyway, now the next question is that velocity, the gradient of a vector. Gradient vector is also called vector field, magnetic field, vector field. Everything is magnetic field, vector field. Magnetic field is also a velocity vector or gradient vector or a vector field, electromagnetic field, everything. We will see divergence and those things also. Okay, these are not basic block of calculus, but this will give you economy. That is the idea. Okay, anyway, because now you can predict something. If you know that the nature of velocity vector of the water, you can say that if you drop any leaf, it will rotate or not. If it rotates, at what point it will rotate at what velocity. So it comes as commercial. You can, looking at the velocity vector of market, looking at velocity vector of a stock exchange, looking at velocity vector of economy, you can now you can forecast then when and when what will happen. These are now entering into machine learning, artificial intelligence, neural network or abstract neural network or deep learning. Okay, so now the next question arises is what is the length of this line? If I have a x-axis, y-axis, if there is a line like this and here it is 0 comma 3 and here it is 3 comma 0, then what is the length of this line between y-axis and x-axis? Can someone find it? What is the equation of this line? Equation of this line is x plus y equal to 3. X plus y equal to 3. What is position if this is x-axis, if this is x-axis and this is y-axis and if this is the line, any point P, what is the position vector? This is position vector of point P. If there is a point P here, then this is the position vector of point P. What is position vector point P? That is xi plus yj. Xi plus yj. Y equal to 3 minus x. X plus y equal to 3. If this is the equation of the line, then y equal to 3 minus x. Then it is xi plus 3 minus x j. Position vector P equal to xi plus 3 minus x j. dp by dx equal to I minus j. dp by dx equal to I minus j. Magnitude of this velocity vector is 1 square plus 1 square square root. Okay, so it's 1 square plus 1 square root. Then it is square root of 2. Okay, if it is square root of 2, then if I calculate the integration, then it is, I don't know, I am correct or not. Now it is square root of 2. If it is the square root of 2, this is the magnitude of velocity vector. Now let's calculate the integration to calculate the distance. Square root of 2 dx, lower limit, higher limit of the x. Then it is square root of 2 x is the integration. Lower limit is 0 and higher limit is 3. This is what I have never tried this. This is x-axis and this is y-axis. I don't know result will be correct or not. Okay, if this is x-axis, this is y-axis, then x is 0 and x is 3. If that is the case, then integration is from 0 to 3 square root of x. Then it is 3 square root of t, 2. This is the length of the line. 3 into square root of 2. I don't know. Okay, let's calculate. Okay, if it is 3 and if it is 3, then through Pythagoras theorem, this length is 3 square plus 3 square root. 3 square plus 3 square, it is 18 square root. Then it becomes 18 square root becomes 9 into 2 square root, 3 square root of 2. Correct? Right. So we can calculate, but what is superior to Pythagoras theorem? What is superior to the theorem which calculates the length of the line? What is superior to which calculates the length of a parabolic line? What is superior? Everywhere there is one theorem. Pythagoras theorem, I don't know, circular theorem. We will see Euler theorem and this theorem, that theorem. Calculus is father of all theorem. If you understand calculus, can you see? You can calculate the curve length of anything. Thousands of theorems washed away. Power of algebra, power of algebra and power of calculus. Power of area concept from which I was reading a book actually some time back, and then it is from some United States university. If you go to their university web page, and then they also talk about calculus and those. I started when I started. Then it is what is calculus? Calculus is nothing but would calculate the rate of change. That is calculus. Then I stopped reading because calculus is certainly not rate of change. Calculus is nothing but calculating the net collection through area. If you have algebra and you have independent and dependent component, if you draw the area, then that area gives you the net collection. That is the integration. So in that book, it starts with derivation, that is the calculus, rate of change, calculating rate of change. But in our book, the calculating the net collection through area, that is integration. So integration starts from integral, calculating the area. Now can you see that if I have a position vector, anyone can try now. Okay, you can consider a questionnaire. What is the length of a parabola? What is the length of a parabola from one section to another section? What is the length of a cone? If there is a cone like this, if there is a cone like this, cone in 2D, cone like this, if there is a cone like this, then what is length? Anything now you can calculate. Okay, so what is remaining is that we will try calculating the surface area. If this is if this is uh, so if this is a surface, if this is a surface, can you see? If this is a surface, can you calculate the surface area? Consider this as a parabola. It is a sphere. Then how you can calculate the surface? Surface is nothing but curve length only, but in 3 dimensions. In 3 dimensions. So that we will see.